Hey guys, so we're going to go ahead and solve this constrained minimization problem. So the first thing we're going to do is we're going to write out our Lagrangian. Sorry, there's only x1 and x2 in this one. And it's going to be a function of x1, x2, and lambda. Note that it's not a function of w1, w2, or y because those are taken to be constants. I can clarify here, we're choosing x1 and x2 that solve this problem. We don't have control over the other variables. So we set this Lagrangian to be w1x1 plus w2x2 plus lambda times the constraint made to be equal to 0. So we would do minus y to make this equal to 0. So then the first order conditions are that for x1, x2, and lambda, the partial derivative with respect to that has to be 0. So for x1, x2, and for lambda. For lambda, we get this partial derivative is just x1 to the alpha, x2 to the beta minus y equals 0. And then for x1, the first order condition is w1 plus lambda alpha, x1 to the alpha minus 1, x2 to the beta. And I just differentiated this L with respect to x1. That becomes w1, this becomes 0, and this piece, power rule, becomes that. So then we do the same thing for x2. We get w2 plus lambda beta, x1 to the alpha, x2 to the beta minus 1. So now we have to solve this system of equations to find our candidates for optima. So these are all going to be equal to 0 as well. Forgot to copy that over. So what we can first see then is w2 over w1 is going to be equal to negative lambda alpha, x1 alpha minus 1, x2 beta, over, that should be on the bottom, my apologies. And these are just algebra tricks, is all this part is. So there's that. And that just came from moving these to the other side and then finding w2 over w1 by dividing these two. So we can get rid of these negative lambdas. We can get rid of all but this x1 up here. And we can get rid of all except this x2 down here. So putting it together, we get beta x1 over alpha x2. So then, the way we would proceed here is by expressing x2 as a function of x1. So then we see x2, move that to this side, equals w1 over w2 times beta x1 over alpha. So then we can plug that into this equation up here and proceed with the algebra. x1 to the alpha times x2 to the beta, which becomes this to the beta, is equal to y. So we'll continue on the next page. And we would proceed with the algebra here to solve for x1. So I'll just kind of quickly run through that, but I haven't double checked this piece, so take it for what it's worth. something of this variety. I'm going to go ahead and skip the rest of the algebra just because it's a little bit tedious. And whenever you're working problems, you're going to get values of these alpha and beta, for example, 1/2, 1/3. And that might make this computation a little bit easier, but it's truly not that bad. I don't want to subject you guys to me doing algebra for 10 minutes. So you would proceed to figure out what x1 has to be, which is a simplification of something like this. Use that to figure out what x2 has to be, and then you see if that actually is a minimum. And that's how you would proceed with this Lagrangian. This part is really the meat and potatoes here. Once you get these, it's just algebra until the end. Hope that helps.